Hello everyone. I think we're going to go ahead here and get started. Once again, we're actually starting off. Thank you for attending another one of our Lab Chart Mastery series. Today we're going to cover cardiovascular analysis, optimizing your blood pressure and pressure volume recordings. My name is David Ream. I'm the technical support engineer for 80 Instruments North America, and I'm based out of our Colorado Springs, Colorado office. And I think more than a few of you out there know me. I see some very familiar names out there in the attendee list. So before we get going today with the actual webinar, I want to talk about some particulars, both with the webinar, how you can interact with me, as well as some kind of boilerplate we're going to cover and some schedules as well for upcoming training. So first of all, I want to talk about the webinar guidelines. As you probably all already know, all audio from attendees will be muted during the presentation. This is just to kind of keep background noise down in the presentation and just to kind of keep us on track. If you do have some questions, please ask them, but I would request that you go ahead and do it in the GoToWebinar toolbar. Down here is the Macintosh version on the left-hand side here, and on the right is the Windows. They're very similar. Just definitely type that question in there, and at the very end of the presentation, I will cover them in turn. Here's some upcoming training courses that we actually have. We just had one here in Colorado Springs, Colorado, so if anybody out there actually attended it, thank you for coming. But these are actually paid courses where you would go to one of our locations or to a training building that we're renting, and it'll give you everything from the basics of Lab Chart to advanced analysis, for instance, some of the things I'm covering today. So the first one coming up here at 13th, 14th of March will be in Boston, Massachusetts. And of course, this is course levels 1, 2, and 3, so starting from very basic Lab Chart to advanced analysis. Then we're going to have our first ever in Dallas, Texas on the 19th and 20th of March. Then of course we have another Lab Chart training course here in Colorado Springs, Colorado at our training center on the 10th and 11th of April. And then lastly, we have another one in Boston on the 24th and 25th of April, 2013. Regarding up and coming webinars, we're going to do actually a first for us as well, priming and operating your Radnadi working heart system on the 27th of March. Any of you out there doing working heart, Langendorf, you name it, this is definitely something you want to watch. We're not going to go over we're not going to go over actual assembly, but we will cover, once we have it all together, how do we prime it? What does the fluid flow look like? How can I configure my Radnadi glassware to perform the experiment I'm looking to do? And then after that, we're going to have a video capture module webinar, very useful, syncing videos with the actual data in Lab Chart and kind of seeing what's going on in the video at the exact moment we see what's going on in the data. Now, if you're curious about any other upcoming events, whether they're in person or webinars such as the ones that I'm showing here, please go to www.80instruments.com/events, or you can just go to our website and click on the events page, and there will be tabs for trade shows we're attending, actual training courses like I showed on my previous slide, and upcoming webinars as well. And these next couple of slides we've added just because we've had customers ask these questions quite frequently. You don't have to read all of this. All we really need to talk about here, or the basic take-home message, is 80 Instruments products are not intended to be used as medical devices or medical environments. Do not use our equipment to diagnose, treat, or monitor a subject. They definitely can be used in the clinical environment for research, but not for actual diagnosis or treatment. Also, quite frequently we get questions about, I have my equipment, who can I connect it to? How can I connect it to people? We definitely use the international safety symbols for either body protection or cardiac protection, as you can see here. So if there's direct electrical connection to the heart, of course we have the heart symbol here. If it's approved to be connected to human beings where there is no direct electrical connection to the heart, we of course have the body safe, and we also comply with the European Union, United States, and also Canadian safety standards for medical devices. Another question I get quite frequently is, I have my Power Lab, how do I know that what I'm getting out of it is actual, is true? What standard is this held to? 80 Instruments has actually, we pay to get certified with the quality management system ISO 9001, and they look at our manufacturing, and they look at our validation protocols to make sure that we conform to the standards that I've listed previously here. This is not a very inexpensive thing for us to do, but it's something that guarantees that the equipment and software you're getting is of the highest quality, and what you're seeing in it, the measurements you're making, are actual. So if you ever have people questioning you about, well, how do we know this stuff is certified? How do we know the signals we're getting? Point them to this. We can also supply certificates as well to say that we've actually complied with this. So that takes us through our preliminary topics, and now we're going to actually cover the actual main topics of the webinar. So today we're going to cover the blood pressure module, its settings, the different plots that are available through it, and also some of the channel calculations that you can perform with it. Next, we're going to cover the PV Loop module. We're actually kind of excited about this. We just released a new version of the PV Loop module, and there's been some rather large changes in it. We're going to talk about settings, the plots that are available, and also channel calculations. So without further delay, let's go ahead and move on to lab chart. So as I said, first thing we're going to cover is the blood pressure module. Now, a note regarding blood pressure and PV Loop, the Windows version of our software, both allow you to perform online and offline analysis, and I'll show you how to turn that off or on in the modules, but of course we're starting out here with the blood pressure module. So my example file here, we have ventricular pressure data, left ventricular pressure data that is, up here in channel 1, and we have arterial pressure data down here in channel 2, and I'll be using these to show you how to set up the blood pressure module and actually do analysis. So the first thing, once we install and turn on the blood pressure module, you'll notice that up here we actually have the blood pressure module settings. Also, in the toolbar, unfortunately I have it turned off right now, but I'll show you how to turn it on if you don't see it. If I right-click here in the toolbar, right here, so I right-click, you see we have options to turn on the toolbar icons for blood pressure and PV Loop. I left-click that, and we get toolbar icons for settings, classifier view, analysis view, the table view, and also to analyze. If I right-click again, we can also do that for PV Loop. So just little shortcuts, easy toolbar tips that we can come up here, click on, and go to specific views or settings for both instead of having to go to the actual menu. So first things first, we'll go to the blood pressure menu, and I'm going to settings. I can also get there via the settings button in the toolbar. And we open up the blood pressure settings window. First thing you'll notice here is we have to actually assign a source channel. I'm going to use ventricular pressure for right now. Moving over, offline analysis, do we do whole channel or selection? Neither one of these is right or wrong. It's whatever you want to do. If you have rather large files, I would recommend, or files that have noisy sections of data that you want to exclude from your analysis, I would highly recommend using selection. And we'll go ahead and use selection right now for that. To the right here, we can either choose between ventricular or arterial data, and we'll go ahead and explain that further down the road. But since I'm using ventricular right now, I'm going to apply that, and that will give us some options that we only use for ventricular analysis. We have a preview here of how cycles are being detected. If there's a green dot above it, it's definitely being detected. Cycle detection, minimum peak heights, minimum periods. If you have problems with specific data, we would definitely come in here and tweak these features to make sure that you end up actually recognizing the data that you're looking for. Just to kind of show you what things look like. If we change this, let's try to get this up to something higher. So you can see here, once I made that minimum peak height up to 200, we're not identifying anything in our preview pane. But if I go down here to 20, we're detecting everything. So we're actually detecting every peak as it should be. But like I said, if you're detecting artifacts that you don't want to, you can definitely tweak these two parameters here to miss them and actually only look at specific blood pressure pulses. End of diastole. How do we find that? We can find it from the pressure signal using LabChart's built-in algorithm. We can also use the ECG signal if we have it recorded. We can tell LabChart where it's at, and we can tell where to trigger off the maximum or the minimum of the ECG. Since we don't have ECG data in this specific file, we'll stick with find from the pressure signal. One of the features in blood pressure that it allows us to do is to actually average over a number of cycles. Default is 4, but you can set this as high or as low as you want to. We can just do 1, so it won't average at all, or we can do 4. I'll leave it at 4 for the purposes of our demonstration here. And of course, tau being one of the options we might be interested in with ventricular pressure. We can use different fitting options. Neither one is right or wrong. Just pick one and stick with it. And we can also tell LabChart where the fit range should end after end diastolic pressure. So now that I've gone that, I'm going to hit OK, and we'll kind of highlight the differences between selection and whole channel analysis, and this will apply to every other module that we're going to talk about today, as actually pretty much every module we make. So I've told it that we want to do it for selection. So I haven't made a selection. We don't have any analysis happening here. However, say this region of data is what I'm interested in, and I want to analyze this selection. I can select it. We can go to blood pressure and click Analyze, or I could go to the blood pressure menu and tell it to analyze selection. Left click, and you'll see here that we've analyzed this selection. You'll also notice at the beginning and the end, there are the actually event markers are grayed out. Those are not being included in your actual analysis, and just basically the reason for that is the module needs at least 2 beats to kind of start performing the analysis, and that's exactly why here. So, but those will not be included. So if you want to include those, you might want to make the selection a little bit bigger. Now if we go back to blood pressure and go to settings, we can tell it to do the whole channel. Hit OK. And of course, I'm going to go ahead and change the compression here so we can see the whole channel is analyzed. The entire file, I should say. Now if we were to go back, go to settings, and say I want arterial data, I want to do that, I can go ahead and change our radio button here to arterial. You notice our options change here. We actually can now look at the dichrotic notch if we want to, and we can determine its minimum height has to be 5% of the peak height for the algorithm to actually look for the dichrotic notch. I think for our specific file, though, we're going to go back to ventricular. All the same things apply with arterial, so I don't really think we need to go through and do our own separate analysis there. So we hit OK. Okay, so we've analyzed things. Now what do? How do I pull things out of blood pressure to tell me the disease state of the animal, to give me the information that I want to perform the analysis that I want? There's a couple ways to do this. The first is going to be the classifier view. And I'm going to go ahead and do a smart tile so we can see both the data and the classifier view. What the classifier view allows us to do is to remove artifacts from our analysis. So say we're moving along here and our detection settings still allows an artifact to get detected and being classified as a good beat. We can actually remove it here. You can also see here if I go up here to blood pressure, I can tell it not to show cycle markers, these are actually green dots, but I have it checked right now to classify all cycles as good. So everything's good. If I don't want that to happen, if in my classifier view I see an outlier, like say this one right here, that's not a good beat, I don't want it to be included in my analysis, I can move my mouse until I'm over the red line of this box. You'll see I get the double arrow, left click and hold, and I can drag this down, and now that beat is excluded from the analysis. And you'll also see under blood pressure that this is no longer checked to classify all cycles as good. We're actually determining according to a graph of cycle height versus cycle duration that those are not good. And it's based more of a graphical interface of those two settings we can make in the settings window, but sometimes it's a little bit easier to do it this way, to actually remove beats that are not good for our analysis. So I can just, once again, left click and hold, slide, left click and hold, and only look at the specific ones that I deem good. And you'll notice, nice thing about the classifier view is each one of these X's is actually linked to the chart view. So if I go over here and mouse over one, double left click, it'll take me to that beat. And you'll see in the chart view, I have that little decreasing radius circle that appears at that beat to let me know, okay, that's what we're looking at right now. You'll also notice the ones that are not classified as good anymore are now red out here in the chart view. And if we move up and include them, they become green, saying yes, they're being included, no, they are not. If you're recording data and analyzing in real time, this view will populate in real time, just to kind of let you know what's going on. So you can have it open while you're recording. And I'll probably do a really quick recording with our playback file feature later to kind of show you how that looks. All right, so now we've kind of gone through and classified good beats. We go to blood pressure, and we can look at the analysis view. So you also see that it's detected things. So the view we're looking at here, the black line is the average of 4 beats. And it's probably very tough to see right now, but there's actually 4 green lines that, of course, kind of roughly parallel this line. And those are the four cycles that we're averaging across. You can see end-diastolic pressure being marked here, max dPdt, max pressure, min dPdt. The blue line right here is tau, and of course min pressure that's reached during the cycle, or the average min pressure for those 4 cycles. If I go down here and move forward, you can see here in the lower left-hand corner, I'm going to go ahead and circle this, or actually spotlight it. You can see, so we're looking at the average of cycles 10 through 13 right now. We're using 4 of 4. Once again, down here in the lower left-hand corner, we also, of course, have the scroll bar here. We have all the usual range or y-axis and x-axis adjustments that are available on the chart view. So, sorry here, I'm getting a little distracted by a chat question there. And as I look through, you can see here too, for regions that I determined to be not good beats, it still looks at them, but they will not influence the analysis. So we can see here for these 4 beats here, they're all red. They're not contributing to the average. We may have just one in there that is actually contributing. All good here. And we can just mouse through and just basically look at the basic shapes. A nice graphical depiction of what the shapes are like, what the average looks like, and where things are falling. So this is great to look at, but I want the raw numbers. I want to pull this information out for my different cycles and my different averages. And the way we would do that is to actually go to blood pressure and go to the table view. Once again, you can also get to the table view and also the analysis view via the toolbar icons. Left click, and here we are. It'll show us time of date, max pressure, min pressure, EDP, min pressure. We can actually move these out, or mean pressure, excuse me, max minus min, systolic duration, all the blood pressure parameters you're going to need for your analysis and for your research. We can also include averages of each one, minimums, maxes, the count down here. So everything you're going to need, and also how many were used. So probably for our last, you can see here where we said that those beats are not good. It's only using 2 of the 4 beats in that average, 3 of the 4 beats in that average, 2 of the 4. And just letting us know how many in that 4 beat average window, how many are being used to actually come up with that value. If all this is too much for you, say I only want tau, I only want the mean pressure, you can adjust that by going down here to options, the options button. I'll go ahead and highlight that so we can all see it. So if we go down there and click the options button, I can tell the blood pressure module what I want to see. So say I'm only interested in max min pressure, EDP, systolic duration, diastolic. We're not really interested in that. Any of these, maybe contractility, IRP. And say I really don't want to see the summary information down here, these averages, these min and maxes for the specific parameter. I can uncheck that as well. I hit OK, and we change our table to something that we really want to see. Now you can export this table. So say you want to take these out and you have your own Excel macro that you want to use to perform further analysis that you may want to do. There's the export button down here in the lower left-hand corner. And if I left mouse click that, it'll bring open and allow me to either save the blood pressure table view as a text file or comma separated variable text file as well. So whatever you want to use. Excel has its own built-in parameters to actually bring these files in, so you don't have to save it as an Excel file. Excel can open text files in a variety of formats. So if you want to graph a certain way or do something unique to your analysis that Excel can do, you definitely can pull this data out of LabChart and do it that way. As many of you know, if you're current LabChart users, there's also an Add to Datapad option. Datapad is our own built-in spreadsheet program, or excuse me, feature. You can get to it from the toolbar tip here, Datapad, or from Windows, Datapad. Let me go ahead and do a smart tile here so we can see everything. So here's our blood pressure module table view. Here's Datapad. I can actually transfer this data right here that's in the table view, add it to Datapad. You see it populates out here. Now, one of the nice things about Datapad is we can actually go in here and do formula, much like Excel. So if you want to do some mathematical operations on these, you definitely can. You can do it in Datapad. You don't need to take it over into Excel to do that. The only thing that you might be limited to right now, and we're working on this, is actually doing any sort of graphing according to the things that are in the table view or in Datapad. Excel is a little bit ahead of us right now, but we are definitely working on adding those features to LabChart. So that kind of takes us to the end of what we can do with Datapad. Now I'm going to go ahead and close this file, and I'm going to open it as a playback file. And playback is a new file extension. I'm going to go ahead and quickly change this to a few less channels. And basically what playback is going to do, it's going to play this data file back in like I'm actually recording it. So the reason I'm doing this is I want to show you some of the channel calculations that we can do and analysis we can do in real time with this file. So if I go ahead here, I'm going to go ahead and set up blood pressure settings. I don't have any data in here, but we'll just use the default settings for blood pressure. We'll do whole channel analysis. That's okay. But one of the first things I want to do, if I want to analyze while I'm recording, I'm going to go blood pressure and tell LabChart that. So we want to go to this option right here. Make sure it's checked. Analyze while sampling. I'm going to go ahead here. There's also, if I left click on a channel title, there are blood pressure channel calculations that are available. So I can left click here. I can use the blood pressure module to calculate any of these and have them update in real time according to how we've set up the averaging. So this would be every 4 cycles that are detected. So let's just say I want to know the max pressure, and I'm going to see it in real time. These are the amount of decimal places I want. I can auto scale, or I can set the scale manually myself. If you forget or have other questions about some of the settings, and actually also in a variety of other settings windows, you'll notice these little question mark buttons. This will take you to the blood pressure topic in our help menu. So I'll hit OK. We can do a variety of things. So I'm going to go ahead and set up another channel here. I want to know the heart rate according to this. So we hit OK. And I start recording. Blood pressure comes in. Blood pressure is identifying in the top channel. And we can see that it's actually populating down here. So we're actually getting our max pressures, and we're actually getting our heart rate, which looks about right. I believe this is a RAT file. You can also see out here in the classifier view, as we're recording, it's populating. And since we're saying consider all beats as good, they're all staying inside that red box. And you can also see that our table view is populating in real time as well. We just keep adding rows. So very powerful. The channel calculations are great if you want to look and see what's happening in real time as you're performing an experiment. Make sure what we're doing is what we want to do and get the responses that we want to get. So that actually brings us to the end of the blood pressure module. It's a pretty straightforward module. There's not a lot of settings you need to change. And we've tried to really work on the user interface to make it simple for you. If you have any questions, please go ahead and put them into the questions pane on the Citrix interface. So now that we've completed this, I'm going to go ahead and stop it. We're going to close this file, and we'll move on to the PV Loop module. Okay, so I have some simple PV Loop data that we've saved here. Regarding the PV Loop module, as I mentioned earlier, we have done a lot of work in it, and you can use it the way it's always existed here to do saline calibrations, to do cuvette calibrations, all the other things that are out there for you. But we've actually added a new feature called Workflow that we've kind of listened to our customers, and it can be a difficult thing to do calibration properly and to make sure you're doing it in the right steps. And Workflow has been added to actually help you do that and help you analyze your data in the best possible way. So by default, it'll be turned on. I have it turned off right now. You'll notice, just as I said before, we have a PV Loop settings and toolbar icons up here for the loop view, and we also have our PV Loop menu. And you'll see down here there's this Workflow mode option. If I left click on that, it asks me if I want to turn it on. It'll say exactly what I've said here. And this is available in PV Loop 2.0 is when we added Workflow. I do want to enable it. I have the checkbox checked. I hit OK. And hopefully I can get it back out here. Sorry for the hesitation here. There we go. Sorry. A little bit of an improper way to do it. So first thing you'll notice here is PV Loop Workflow here off to the left. And you'll notice we have a bunch of different little steps that I can click on to go through. And it's just designed to actually just to guide you through the process of analysis of calibration. This has been something that we've talked with customers a bunch about, and many have asked for some way to make this easier. PV Loop can be a bit daunting when it's your first time, so we've given this to you to help you setting up the MPVS software as well as with ours and actually using the PV Loop module. So the first thing we come to when we have workflow open is how to set up PVLoop, the actual module in LabChart. You'll notice here we want to select the proper type of workflow. For those of you who have done large or small animal work, you know it's different. The actual MPVS hardware from Millar requires different things. So small mammal will use a cuvette calibration, large mammal we won't. But for this file, I believe this is from a mouse. Of course, we're going to use small mammal. We tell LabChart, okay, well, pressure channel is on channel 1. Volume channel is on channel 2. So we want to go ahead and make those indications to LabChart so that when we go on to pressure calibration, conductance, sampling, et cetera, we can go ahead and it'll know where to look for the proper data. So the first step, always, it's set out for you here. This is what you need to do first. Of course, we would have the MPVS software open right now. I won't cover the MPVS software during this presentation. We do have a webinar out there that talks about it and how to use it. But I'll just kind of mention it briefly, but if you do want to learn more about how to use the MPVS software, definitely look at that webinar or give me a call. So we've determined what workflow we're going to use for small mammals, set up our channels, takes us to our next step, pressure calibration. Tells us even what to do here. We need to launch the MPVS software. Wants us to start sampling, and we want to sample an actual pressure calibration from the MPVS unit. The MPVS unit can output calibration signals under, I believe it's the catheter calibration tab. So we're going to pretend, okay, we've gone ahead, we've recorded this first block here, and we've recorded our pressure calibration outputs. So we've already recorded, and we want to go ahead and do the pressure cal. The way we would do this, here's our first pressure that corresponds to 100 millimeters of mercury. Go ahead and select across it to where we're nice and stable. So a couple of seconds of data here, a second and a half looks like what we have here. Move over here, left click on this arrow. It averages across the selection and applies that voltage value equals that millimeters of mercury. Next, go to our next step, our 25 millimeters of mercury step. Average across it, or make a selection across it, I should say. It averages it, left click, puts the corresponding voltage value to that pressure here. And last but not least, we click the Apply Pressure Calibration checkbox. Once I do that, you'll notice, let me go ahead and do a smart tile here, that now everything here is in millimeters of mercury, as it should be. 125. So definitely helping you through the units conversion process in LabChart, making it a little more streamlined, more specific to your data of the steps you need to do. Now that we've actually calibrated pressure, we're going to move on to conductance, or the actual volume. So once again, we're telling you here, use the MPVS control software to sample conductance calibration values. MPVS software should be open. We start sampling, and in the same block of the example file, we've output on the volume channel the MPVS calibration values to get to RVUs for the specific volume. And these are just placeholder units, just something that will make sense to us while we're performing analysis and doing other calibrations. The MPVS software has the option of either doing millisiemens or RVUs. For the specific file, we're using RVUs. You can use millisiemens. Neither is wrong. So if I select down here across our calibration step, just like the pressure calibration, we go here and left click the arrow button. It gives me an average across that selection, and that equals 5 RVUs. We go up here again, select across the region where we've gone up to 50 RVUs, left click, gives us our average, and we can apply the conductance calibration. And you can see on channel 2 now, all of our data is in RVUs. So relative volume units. And like I said, this is just a placeholder unit that allows us to have something that makes sense so we don't get any negative voltage values. As you can see here, the Millar MPVS unit puts out between plus or minus 10. So that's kind of tough for the actual PV loop equations to work with, so we definitely move it over to RVUs so that what we kind of see makes some sense while we're recording data. So now that we've calibrated volume with RVUs, we move on to sampling. You can see here, this is where we perform our experiment. We collect our baseline data, our occlusion data. We also get a saline bolus data as well as cuvette well data. You can adjust detection settings if you want to in here. There is a toolbar tip here. If I left click, it'll bring up the PV loop settings window. You can also access the PV loop settings window from here. This is kind of the old way of doing things. We can tell it to analyze a selection. Usually the best way to do it for PV loop, because we're going to look at unique areas of data. You can tell it to do the whole channel if you want to. You can see the preview here. We can also set the data sources here in the settings window. And we can also tell it where do we find loop detection. Is it from an ECG or do we do it from the pressure signal? If we do it from the pressure signal, just like blood pressure, what is the minimum peak height? What is the minimum period in seconds? So we can also change it to milliseconds here. Just tell PV loop this is a good event that you need to start analyzing. We hit OK. And we say, okay, we've completed our sampling. So we've gone through, we've sampled a bunch of data. We have a bunch of left ventricular data. Gone through this file is actually relatively long. In this file, this is also the example file that comes with PV loop. So if you want to know more about, look at specific regions, what data should look like for things, they are marked in here with comments. So if I go up here to the comment list, you can see here our pressure calibration is marked. Our conductance calibration is marked. Pre-saline baselines at 5 minutes, 15, 20. Saline calibrations, baseline data, occlusion data, and also cuvette well. So we want to have all this data collected in RVUs before we move on from this point. And this is where it becomes very useful for workflow, because you know when you're supposed to do specific calibrations. When can you do with the animal? How do I need to prepare before I get to the step? And kind of gives you a nice outline to follow to make sure you don't jump ahead and not collect data that you need later on. So we've gone through, we've recorded our data, we've marked it. We move on to cuvette calibration. Cuvette calibration, as I said, is unique to the small mammal PV loop workflow. And basically, there's a specific cuvette you will use with the catheter model you're using. They usually have 4 to 6 wells of different volumes. And basically, it's going to take it from RVUs over into microliters. So it doesn't automatically come up here, but we can bring it up. So to calculate an approximate units conversion by entering known and measured well volume values in the cuvette calibration view. How do I get the cuvette calibration view? I got a PV loop, and you'll see we have this cuvette calibration. I left click on that. I'm going to go ahead and smart tile here so we can see everything. And up comes my cuvette calibration window. So I have known volumes versus conductance, or RVU values. And basically what LabChart's going to do here in PV loop is just going to do a linear regression on the values according to how they should work, both for the RVU value and the corresponding known volume. For this specific catheter, the conductance or the well calibration, we'll see out here, well 1 was not used. So we're marked out here in a comment, and if I go to the comment list and left click on that comment, it takes us to our cuvette calibration. And make it small so we can see it here. We've actually done 2 cuvette calibrations, just so we have a nice broad spectrum of data that we can use. So how do I get these values up into this table? The way you would do it, if you look at your cuvette, first thing you do is go ahead and type in the well values. This will be known for the specific model of cuvette you're doing. Definitely look at your Millar documentation and we'll tell you this. Also, your documentation will tell you which cuvette you should use with your catheter. We didn't use well 1, so we're not going to include data there. So we go through, type in our cuvette values of the known volumes that are in them. Go here to conductance 1. This is our first run through the cuvette. Go to well 2, since we didn't use 1. in lab chart, highlight over a nice stable area at the cuvette cal, and you'll see this button here, set from selection. And it does an average across that region and enters it here into conductance. We go through for each one of our well values, set from selection. Just keep going through here, highlighting, set from selection. Last but not least, well 5, set from selection. Now say we want to go ahead here, you'll notice we have our actual calibration values are being calculated. One cuvette well may be good enough, but let's go ahead and do 2. You can do 3. You can just keep adding them in over and over to get a nice average across for the actual cuvette calibration. This is something new that happened with workflow. So we can go once again to our second cuvette cal. You'll see we're getting slightly different values for that one, so it will average across. And you'll notice too here as well the order that we're collecting this data. The cuvette calibration is at the very end because we're going to have to actually remove the blood volume from the animal to fill these cuvettes. And if we have something like a mouse, it's definitely not a lot of blood volume, and it's not going to be able to live without that. So we go ahead and go through here, and we do this at the very end of the experiment. Saline bolus would occur before this, so you definitely want to record that data before. Now you'll notice, I'm going to go ahead and make this a little bit larger. Here's all of our cuvette calibration averages, and we're doing this nice linear regression of this RVU value corresponds to this known volume value. So this would be our volume calibration. I'm going to go ahead and smart tile again so we can see both. It's giving us our equation, or actually our squared value, which is pretty good. We're pretty close to 1. And we can apply it to our data. So you'll notice, if I go down here and mouse through the data right now, we're still in RVUs. I apply this, now we're in microliters. So we've gone through and done our cuvette calibration. Next thing we need to do is take care of saline calibration. What is saline calibration and why do we do it? With the conductance technology, the Millar catheter, the heart wall will contribute to this. It'll contribute, and it will decrease the accuracy of your volume measurement. The saline calibration is designed to remove that variation, to remove the portion of the volume that the actual heart wall is influencing, and just so we know it's just the blood volume we're looking at. To do this, we of course need to do a saline bolus into the animal, and we actually have some example data of that here. You can kind of see where we did it during the whole experimental run, fairly early on. A lot of times I get questions, what should a good saline bolus look like? This is what a good saline bolus should look like to actually do the saline calibration. You need at least, say, 8 to 10 heartbeats. It needs to go ahead, stroke volume needs to increase. And we need to have this increase as well as in max volume and min, of course, which would give us this larger stroke volume. This is what you need to see. Pressure needs to stay relatively stable during this time. You will see some variation, but you don't want to see a huge decrease because then you're affecting the physiology of the heart. So how much should I use? What concentration of saline should I use? Whatever works. You might have to go through a few animals to actually play around and see what works for you. Of course, we don't want to put a whole bunch of saline in and affect preload on the heart. We don't have too high of a concentration that affects the physiology of the heart as well. So it's a little bit of a play of what you want to do or what you should use. But in the end, if you're getting data that looks like this, you're using the proper amount and you're using the proper concentration. We also had a question in a recent course, well, is this going to affect my experimental data later on? If you only do it once or twice, the saline bolus should not affect volume later on down the road with your actual occlusions. If you're with a mouse and you do it about 10 times, 11 times, yeah, we're probably going to start changing the properties of the blood, which will in turn affect the heart. But if you do it, less than that, get some good data, and then just move on with the experiment, you should be just fine. So we've gone through here. We have, looks like, about 3 different saline calibrations that we've done here. So we definitely can do it multiple times. We need to actually analyze the data at these points. So since we're in analyze selection, you're going to want to go ahead and make a selection. I'm going to go down here the time axis and do it. So we have the start of the saline calibration. So right about here when it's really starting to ramp up and go almost to the peak here. So for a good saline calibration, it needs to be over a few seconds here. We don't want to take a really long time, 20 seconds to do it. It needs to be relatively quick, but not too quick. Don't do it in 1 second. And you want to see, you just want to kind of select over this region. You should have about at least 8 to 10 good beats, as I mentioned earlier. We analyze the selection. We can also look at the saline calibration window. I'm going to go ahead and do a smart tile here. And basically here we have the unity line on end systolic volume and end diastolic volume, where their volumes are exactly the same. With our saline calibration, where these intersect, that is, since we don't have any blood, and we don't have in either of these, we're just looking at heart wall here. Where that intersects, that's the contribution of the heart wall. So that value where this line intersects is going to be, the heart is actually giving us kind of an inflation of about 23.435 microliters for this specific saline calibration. We can adjust the detector settings to make sure if, okay, we're not identifying beats as we should. We can do that here with the toolbar icon. Everything looks good for this specific file. We're going to go ahead and hit add. And we actually get the parallel conductance, or the how much is the heart tissue adding to our volume. Like I said, you don't have to do this just once. We have a few in here, so we're going to go ahead and keep going here. Saline calibration number 2, another good one. We'll go ahead and select across. We want to analyze this selection. We're doing it again. Get another value. Looks really good. Nice linear regression. Nice spread out. We have enough points. Hit add. And let's just go ahead and do a third one. Saline calibration. Like I said, if your calibrations look like this, you're doing a great job. This is exactly what they should look like. Or your boluses, I should say. Go here, analyze again, and add this third one. These will not average by themselves, but I would recommend doing a few and then just kind of picking the median value. So looks like the very last one, 22.05 microliters, looks pretty good. It's in between the other two, and we'll use that one to apply our parallel to conductance or our saline calibration to remove the influence of the heart tissue. Apply. And we're done with that. Alpha calibration. What does this mean? If while I'm recording with PV Loop, or actually recording PV data, and I go through and do all of this, and say I'm doing an echocardiogram as well, which can give me volume figures, we can use the alpha correction to go ahead, or alpha calibration, to make the volume measurement even more accurate, because we have this known good volume calibration from the echo equipment, and we can actually apply another factor in there that's going to further alter the volume of the malar catheter and make it even better. So basically all we would need to know the stroke volume for the malar, and this is after we've gone through all of this, we can go back and look at stroke volume over some baseline data. Stroke volume for your reference, so like I said, echo, or I believe thermodilution can be used as well. just so that we know what the stroke volume is. We can go to apply it here. By default, it's 1. It's 1-to-1. We're not saying there's any variation, but we can apply this correction ratio if there is a slight variation. And that's entirely up to you whether you choose to do that or not. Neither way would be right or wrong, but it's definitely up to you. And finally, we can go ahead and analyze our data. So we can go through and look at specific regions. Thankfully, this file is marked really well. I'm going to go ahead here to PV loop, and I'm going to bring out the loop view. There's a variety of plots we see here as well. Loop view. I'm also going to bring out the table view as well, the hemodynamic table. And we'll smart tile all this stuff. So loop view, as our loops are building, obviously we're doing a saline calibration, so all we're going to have is increases in volume here. There should be no pressure changes. That's the loop view of a really good saline calibration. But let's go to some baseline data. With the analysis, we can actually tell what we're looking at. Is it baseline? Is it an occlusion? We go ahead and make our selection, analyze the region, and there's a very, very good piece of baseline loop, PV loops. You can also see we're updating here for each loop in the hemodynamic table, much like the blood pressure modules PV loop, or excuse me, hemodynamic table. You can export it as a text file if you want later on. There are options for what you show. I'm probably just going to do a few things here. I want to drop it down. Tau, of course, and all the hemodynamic parameters that you'd want to know for your PV loop experiment. We also, of course, have a summary down here that we can keep or remove. We can also add this to the data pad, much like the blood pressure module. So we have good baseline data here. Are we getting good things? We can go ahead and adjust the detector settings here, or of course we can go to PV loop and adjust settings here as well. Analysis Manager is something in LabChart that would allow us to save specific analysis regions. So for instance, we're looking at baseline here. I bring up Analysis Manager by clicking on the button. I want to save this and actually go back to it and not have to reselect and reanalyze or anything like that. We can left click this. We can call it baseline 1. Hit enter and it saves that specific analysis selection as baseline 1. If you want to get to the Analysis Manager some other way, you can go to Window, see if I can find it here, Analysis Manager, and it will appear again. So we're looking at baseline data. Well, let's look at an occlusion. We go to PV loop. Excuse me, we go to the comment list. We have occlusion. It looks like we have 2 in here. Occlusion number 3. Make our selection. Tell PV loop that we are not looking at baseline. We're actually looking at occlusion now. So it draws the appropriate ESPVR and EDPVR lines. Analyze the selection. And there's our PV loops from our occlusion. Of course, we can go in here, we can remove loops that might be outliers, and they will not influence the analysis. We can change the ESPVR fit lines, the way it's being done, linear, quadratic. We can tell LabChart that I don't want to see it, or I do. Also tell this if it's linear or exponential for the EDPVR. I don't want to see it, or I do. And another interesting feature for this, say I want to put this view in a paper. I want to show it in a presentation where I don't want to open up LabChart. I can actually go to Edit, copy PV loop view. I can also copy PV loop regression. I can paste these into a Word document, into a PowerPoint. It'll just copy it as an image, and we can put it in there, ungroup it, remove things, change fonts, things like that. It's just another little bit of another feature that allows you to really, for the data to be very flexible and for you to use other programs that might do something that LabChart doesn't or doesn't do to your satisfaction. So Also, like I said, great for papers and adding them in. So I've done this occlusion. I'm going to add another analysis. We'll call this occlusion 1. Hit enter, and it saves it. Say right now with Analysis Manager, wait a second, I want to go back and see baseline 1. I can go back, look at baseline 1. We change back to baseline data, and we can look at our values from that. I want to go look at occlusion again. We've saved that analysis. There it is. So that's how you would use Analysis Manager with PV Loop. You can also use Analysis Manager with Blood Pressure Module as well. So I'm going to go ahead and close it here, and we'll talk about more of the things in PV Loop. We talked about the hemodynamic table. We have a variety of plots. You can analyze while sampling. We'll not cover that because this file is so large you won't really get to see a lot. But you can. The loop view will populate. The table view will populate. There's also channel calculations that we can do as well in real time, and I'll show you those in a few seconds here. You can reselect Analyze Data. So if I go ahead here and move my cursor around the chart view, I say, well, wait a second, I want to go back and reselect that. It'll take me back to the loops that I've analyzed that are good here and reselect that region. We can clear the analysis, analyze selection, and of course, as we've seen before, you can turn on or turn off the workflow mode from here. So I'm going to go ahead and close the table view, and we'll talk about PRSW plot, preload recruitable stroke work. So we can actually look at stroke work versus end diastolic volume. DPDT max versus end diastolic pressure, or excuse me, end diastolic volume. PDA versus EDV, end diastolic volume. And PVA versus ESP. I'll go ahead and do a smart tile here so all these show up. All of these are plots that are available to you. If you want to take these out and put them in a presentation, you can do that as well. You can go edit, and it'll copy that plot. We can take it out as an image, put it in a Word document, put it in a PowerPoint. And for each one of these windows, you'll notice we have a link to the help menu topic for them. And we can also tell our workflow here to automatically tile the views when we open them up. So as I keep pulling them out, I'll bring it in and it'll tile them. So hopefully, those of you who actually do PV Loop, the workflow model should work very well for you, make things easier, and keep you on track of how to go through and do the calibrations. What points do I need to do them? If you don't want to use it, you don't have to. You can go ahead and turn it off and, of course, access everything I showed you the way you're used to in actually going through and doing the different saline calibrations, stuff like that. You also see once I've accomplished something, we don't see the link. Well, there's saline calibration right there. If I go ahead and click on it, keep that calibration. Shows up. If I'm down here and analyze, it removes those from the view. Say, yes, I've done that. It's been accomplished. We have our green check mark. We're good to go. That brings me to the end of what I wanted to cover today. So that's PV Loop. And I'm going to go ahead and cover the questions here in a second. Let me go ahead and bring up my presentation again. But before I do, if you have any questions about what we've covered today, if you forget something or maybe it's not explained well enough, and you maybe don't remember to ask the question today, definitely give me a call. When you purchase our software and our hardware, you buy my services. So please give me a ring. We never charge for support. Here's my address, my telephone number, 888-965-6040, extension 204. I'm on Skype daily at adi.support.us. And if you want to email me, here's my email address, my first initial, period, last name at adinstruments.com. So do not hesitate to contact me. That's what I'm here for, not just for failures with the hardware or if something breaks or an issue you may see in the software. How do I do something? That's definitely what I'm here for. Give me a ring and just to learn more about LabChart. So I'm going to go ahead and here and look at our questions. Okay. Looks like we have a few audio problems. We should be fine. We are recording this. If you have some audio dropout, we definitely have recorded, so you might have to go in and just watch the recording, but we should have that covered. Okay. So there definitely will be a recording of this webinar being sent to everybody who's attended today. I have a question from Brian. Is there a way we can set up our own workflow in other modules or in the program in general? Unfortunately, no. Actually, PVLoop is our first foray in doing that to kind of see how it works with a module. And if it's well received by our customers, I'm sure we'll definitely look at it for other modules. However, PVLoop is so intricate. There's so many things you need to do. It really lends itself to workflow. But for instance, like say blood pressure, maybe not necessarily, but it's something we're open to and we'll probably explore in the future if the workflow is well received. So that's pretty much the answer to that question. And that's, I think, all we have here. So either I bored you to death and you need to pay attention, or I answered all the questions during the presentation. So if you do think of something in the future, definitely give me a call or send me an email. Please contact me if you have those problems. But in the meantime, I'm going to go ahead and sign off today. I'll leave this slide up for the next couple of minutes so you guys can copy down my contact information. But I'd like to thank you for attending. And if you have any questions, please answer them now. If you think of something in the next couple of minutes, I'll be monitoring the question window here, and I can answer them then. But thank you for attending, and have a good day.